Hi, so today I will be talking about isovaleric acidemia, the organic acid disorder. We'll jump right in here with talking about the description of this disorder. So it is an inborn organic acid disorder, which means it happens when the child is born. It is discovered. It was discovered in 1966 from two different siblings. They had the same recurring symptoms of metabolic acidosis that resulted in coma and stupor. And this doctor recognized the distinctive smell that was associated with this from the specific acid that builds up in the body. So it has a distinctive sweaty feet smell, and that is from the isovaleric acid building up in the infant's body. It is fairly rare. It affects 1 in every 230,000 infants, and it involves the digestion of leucine, which is an amino acid that we supplement by eating in our diet. So there are a few major characteristics of this disease. One is what we already talked about, the sweaty smell in the breath and urine of the child. It is characterized by a lack of the enzyme to break down leucine. So that enzyme is isovaleric-CoA dehydrogenase. And this enzyme is used to break down proteins, more specifically the amino acid leucine. And leucine is an essential amino acid, so we have to obtain that from our diet. And our body produces an overabundance of isovaleric acid due to the inability to break down leucine, and we cannot digest it properly. And so isovaleric acid will in turn build up in our body, causing significant problems for our organs and such. So there are two different forms of this condition. There is the acute neonatal form, which is found within 2 weeks of birth, either one day. It can be anywhere from the time that the baby is born up to 2 weeks, and it can be very, very life-threatening for them. At any time they ingest mother's breast milk or formula, they can start to have this problem because we do not make leucine in our body. Once we take it into our diet, then the infant will start showing signs and symptoms. Symptoms of the acute neonatal form would be the severe ketoacidosis, which is where we get the smell from. They could start having convulsions, and they also will get very, very tired or lethargic, and they could also have severe dehydration. So a lot of these are fairly significant issues, and it can be life-threatening for the child as well if immediate treatment does not happen for them. There's also the chronic intermittent form, and this is kind of found throughout their life, usually found when they're a newborn, but they will have symptoms throughout their life. And this happens when they take in protein in their diet. Anytime they take in protein, their body cannot digest the leucine, and so they will display mental retardation after ingestion of this protein. So there is a molecular cause for isovaleric acidemia, and that is on the IVD gene. Our body has chromosomes that make up the DNA of our cells, and what we look like, what we do, the way our body functions, all of those different things. And this particular gene is located on the Q arm of our chromosome. So this is on a regular chromosome, not on a sex chromosome. And this gene, this specific IVD gene, gives our cells instructions for how to make this specific enzyme, the isovaleric-CoA dehydrogenase enzyme. If we do not make this enzyme, then we cannot digest leucine. So this is deadly to the central nervous system, and it makes it incapable of operating, and that's essentially what causes isovaleric acidemia. There are also 6 different variants in the gene mutation. I'll quickly run over those. So type 1 is a mutation where there are the same normal size proteins, but there's just a substitution in the base pairs of the DNA. So that means we have something else coming in and something going out. So there is a change in the gene corresponding to the sequence change of our DNA, and which makes a shorter protein, and the proteins essentially operate inefficiently from that. And so they cause the protein to be useless. In the other variants, most of them are shorter. Some of them prematurely stop, so it stops early on, and there's no protein after that. And the other thing that happens is that there's a frame shift mutation, which means that something can be added in or taken out, and it'll change the entire protein from there on out. So there is only one mode of inheritance for this kind of disorder. It is autosomal recessive inheritance, which what that means is we have chromosomes in our body. We have sex chromosomes and we have autosomal chromosomes, which make up a lot of different things in our body, but the sex chromosomes mainly make up if we are male or female. It is not on those. It is only on the regular chromosomes, which we call autosomes. And both parents for this disorder, in order for a child to be affected with this disorder, they both have to either be affected with the disorder themselves or be carriers of the disorder. And carriers do not typically do not represent symptoms in the disorder. So the dad would have to be a carrier or an affected individual, and then the mother would also have to be a carrier for them to have a child affected with this disorder. So anytime that both parents are carriers or affected, they have a 25% chance of having a child with this disorder, or a 1 in 4 probability. So here is a sample pedigree of what this might look like. So in order to break this down for you, circles are females, squares are males. Anytime you see the red on this pedigree, it means that they are affected with the disorder. Carriers do not have any change in the shape or color, but they are present in this pedigree. So up top here, you can see that these people must be affected with the disorder because they have 2 children that are affected with this. And then over here, Jill must also be a carrier because she then passes it on to her grandchild a couple generations down. Over here, same thing. Travis must be a carrier because there is people affected in the line here moving forward. So with this just shows us that it's an autosomal recessive disorder because it skips generations, because people can be carriers and not be affected with the disorder itself, and they also may not know that they are a carrier themselves. So there are a lot of genetic testing available for this, and there are 64 available. The most common, though, is the newborn screening panel, and this is typically mandatory in most states. There are some ways of opting out of this for parents if they have religious or financial concerns, but it's typically done before the newborn leaves the hospital. It's done with a heel prick. The doctors will take some blood, take some samples of that, and they test for a multitude of disorders. In my state, I live in Oregon, and there's 49 different disorders that are tested in this newborn screening panel, and isovaleric acidemia is one of them. And there are a lot of other organic acid conditions that are tested as well because it can be such a life-threatening disease. So they're crucial, like I said, for survival. If caught early, we can treat them effectively and have great results. And the cost ranges anywhere from $0 to $150 depending on where you live. So there are some treatment options available. Nothing is going to cure this disease. There are some management tactics. Doctors and nutritionists can work really closely together to provide the patient and the parents with a low protein diet. There are medical formulas that we can give to infants with this disorder that will help them throughout their life so they do not accumulate this isovaleric acid in their system. There also is medications that we can give for maintenance. Those include glycine and L-carnitine, which are also amino acids, and they help rid the body of any unwanted acid and any other harmful substances as well. And you're monitored fairly closely by nutritionists and doctor during during your life because of the severe risk that it poses on your health. Most kids, honestly, can lead happy and healthy lives with normal growth and development if treated properly and treated early. And then in metabolic crisis, there are some treatment options available for that as well. Immediate treatment is needed if a patient takes in protein unknowingly or accidentally. There is IV of bicarbonate and glucose, and this will lower the amount of acid in the blood. So in children that have multiple episodes of metabolic acidosis, it can lead to lifelong learning and problems or mental retardation. So in conclusion, isovaleric acidemia is an inborn organic acid condition. It is always found in newborns. Genetic testing is mostly mandatory in the hospital and is available. There is early diagnosis, and the early treatment is imperative to the infant's survival. So I hope that was informative, and I enjoyed learning about this condition.